Hey, so this is a supplemental to the volume of a truncated cone lesson. At the end of that homework, it asked you to measure a cup or something around the house. And I said, why don't we try to do that in a separate video? So I'm going to do that. I got my Rudolph cup here. It looks a little dirty at the bottom, but it's clean. So I'm going to get some measurements first. I'm going to measure in centimeters. So I'm going to measure, hopefully you can see me doing this. Of course, I'm not going to be super precise. So the top diameter about 6.7 centimeters. The bottom maybe about, let's say about 5. Let's keep it simple. We'll say the bottom diameter 5 centimeters, and then the height maybe about 9 point, let's say 7. All right, let's see what we got. All right, so using those measurements, I'm going to attempt to calculate the volume of that Rudolph cup. So Rudolph cup. So I drew a little sketch here with the measurements put in. So first, using the fact that we have two similar triangles, we can use, so first of all, actually before I do that, we're going to do 6.7 divided by 2, because 6.7 is the diameter of the top, so the radius would be 3.35. So this is 3.35, and then this 5 divided by 2 is 2.5. Again, that was the the diameter, and we want the radius. Alright, so we're going to use proportions to find the value of this section. So basically that's the section that, if we were to stretch this out, it's the cone that got cut off. So I'm going to do this pink to this green, and then I'm going to do all the way down pink. So that pink side of that long triangle is x plus 9.7. And then of the green one, it's just x. So the proportion is going to look something like this. 3.35 is to 2.5 as x plus 9.7 is to x. Alright, so then we're going to cross multiply. 3.35x is equal to 2.5 times x plus 9.7. 3.35x is equal to 2.5x, and then I got to do 2.5 times 9.7, 24.25. If I subtract 2.5x, so 3.35 minus 2.5, 0.85x equals 24.25. So x is 24.25 divided by 0.85. Let's say about 28.5. So this is about 28.5. If we take that and add 9.7, then we get that this total is about 38.2. So this whole thing, about 38.2. Alright, so from there we can calculate the cone down here, the volume of that. So I'll do that in purple. So this This section I'm going to do in purple. Alright, so the volume is 1/3 pi r squared h. So 1/3 times pi times, now the radius of that cone is going to be 2.5. The diameter is 5, so the radius is 2.5. And the height of that one is going to be that 28.5. Okay, that's what we found here. Okay. And then the volume of the whole thing, so I'm going to color the whole thing in green, is 1/3 pi r squared h, but this time we're going to do 1/3 pi times this radius, which is going to be 3.35, this 3.35 squared, and its height we found is that 28.5 plus 9.7, so 38.2. Alright, so I'm going to type this all in at once. So I'm going to type in the large one, 1/3 times pi times 3.35 squared times 38.2 minus 1/3 times pi times 2.5 squared times 28.5. So according to this, that cup should have roughly a volume of 262 cubic centimeters.
All right, we're going to see if this cup actually holds 262 milliliters of water. All right, Bentley, go ahead. All right, let's get down here. It's just a little bit above 250. I would say it's pretty darn close. Yay!